So today's topic is home performance and HVAC. So what this is going to be is, and what we're going to kind of discuss today is how home performance and HVAC relate to one another and what is done during a blower door visit, as well as how to take measurements with proper precision tools. So today's agenda is going to be typical issues within homes, home performance and home performance specialists, priorities and importance, the blower door and the manometers, and what does it mean and what does it tell us, understanding the home, the physics and science behind it, and understanding the HVAC system. So we're going to start with typical issues within homes that we run into. First, and we all hear it, is comfort. And what I mean by comfort is are you letting those in, Dave? Okay. So comfort is hot upstairs, 5 to 10 degrees or greater variance from a lower level to a upper level, cold downstairs, basement or lowest level of a home, especially in a townhome or multi-level home. Humidity and moisture. We've all ran into that damp or wet basement, water leaks, plumbing leaks, musty smells, sticky floors, walls, even furniture. I think we've heard where people tell us that everything seems damp, even their clothes. Ice dams during the winter months, especially when we get snow. Condensation appointments, things like that, or calls where they're running into, moisture that they see. Obviously, that's our surface temperature dropping below that dew point. We're going to hear that a couple times today. Health and safety are another issue within a home that maybe not as brought up to our attention until we're in a home, and then we just start asking our lifestyle questions to figure out what's going on and what may be causing some of the issues that they have. First point here is sick building syndrome, home making someone sick, such as allergies, asthmas, colds, or flus. And of course, combustion appliances. And we offer CAS testing or combustion appliance zone testing, as well as low-level CO monitoring. Now, what I want to talk about with the low-level CO monitoring is that any CO detector that we actually purchase, and even the ones that we carry on our vehicles and that we offer to our clients and homeowners, does not start to actually go off until a high level. And that's usually approaching 60 parts per million. Obviously, that lets us know if there's something major happening at that point. But what's happening if we're running at 10, 15, 20 parts per million consistently within a home, and that detector is actually not going off? So one thing to keep in mind is that we can offer and can get low-level CO monitoring. And when we run into those, or we feel like there's a home that we should be offering that to, we could always get that information and give it to the homeowner. So what is home performance? Well, home performance is the science of making a home more comfortable, healthier, more durable, and more efficient. Usually in home performance, there's multiple contractors that are going to be involved or working together, solving homeowner issues. And most of the time it's going to be within a budget. So that is very important to keep in mind when we actually start talking about home performance with the homeowner. So planning is crucial. It is very crucial, and it is needed to figure out root causes. Yes, we can do some base testing, some base investigating, get the information from the homeowner, but it could take advanced diagnostics to actually figure out what is going on with the home and what the root cause is. A lot of times what we try to do is we just try to cover the immediate thing, which may be inevitably masking it, not knowing or unknowingly to us, that's what we may end up be doing. So understanding the home and the occupants are very, very important. So home performance specialist. What that is the technician or whoever may be involved with this is going to be involved from beginning to end with the project. It starts from the initial consultation throughout the project and retesting and verification at the end. So what we have to do is we have to prepare predictions. So what we talk to with the homeowner is setting expectations. Okay. And with that is a budget. We do have to talk about their budget. We have to figure out what their house needs are and inevitably their goals, and make sure that we find that sweet spot that it falls within for us to actually do a project. So again, we check air leakage prior, during, and even before. Also energy consumption and tracking, just to know that what we're doing and what we're putting in is working correctly. Accountability. Accountability, it's not just by the actual specialist, it's also shared with the homeowner. And it's due to shared decisions, decision making, budget, house goals, everything that's needed. However, the reputation is built for the specialist or the company based off of those results. So whoever actually does the home performance testing, wherever they are, the reputation is everything with the homeowners and getting results. So we have to make sure that we're testing to know what we're doing. And feedback, strong reviews, referrals. We talk about that all the time. With the more referrals we can get, the more your name can get out there, the more positive feedback is going to be more referrals, and obviously more people that we can take care of. So priorities and comfortable and efficient homes. Air seal the home. Okay, that's number one. What's another priority? Air seal the home some more. Bet you can't guess the third one. Keep air sealing the home even more. Properly insulate, knowing what that insulation is doing, how it's in the home, how it's around the home, and installation of the correct HVAC system. And what I mean by that is, and we'll get into more later, but here we just talk about properly sized. We need proper installation practices from the design to the installation, the pulling a proper vacuum, brazing with nitrogen, all those things that we all do. Optimize with correct ductwork, understanding the connections to it and how that affects the system. Very, very important. And that even goes back to the original comfort consultant going out there to the visit. So hopefully we all want to get better and we all start to understand this and just look at these things that we can be better at. And then once it's installed, proper commissioning and setup. Now that may be through a follow-up visit or with our installation team. Obviously, the installation team has a lot going on to follow those proper installation practices. Sometimes it may require a proper commissioning and setup after a job is completed. So if you didn't get the importance of air sealing on the last slide, that the first 3 points and priorities is air sealing, I'm going to talk about it a little bit more. What's it do? Why do we care about it? Well, it reduces the risk or major risks of discomfort, drafts, cold spots, stack effects, moisture problems, growth on surfaces that we can see or may not see, understanding dew point, and indoor air quality overall. Obviously, what it's going to help improve is comfort. You're not going to get as many of those comfort complaints or comfort calls. energy consumption, which is just a byproduct of correcting all these other things, and improve overall indoor air quality. And we'll talk again about some of that indoor air quality here soon. So if we have a leaky boat, are we just going to try to take a pail and dump the water out? No, we're going to fix the leak. Same thing with your home. And it needs to be looked at upon that way, that you got to fix the leaks first. If not, your boat's going to sink. If not, you're going to be out of control with what we can do in a home. And we'll continue to get those complaints over and over and over. So, how do we know the air leakage? Well, we don't guess. What we do is we test. And with that, we have what we call our blower door. So let's get into how we do that and what that means. The blower door is a tool used to measure that air leakage. What we do is we put a hard or soft panel into an exterior door frame. Once we get that exterior door frame put in place with our hard or soft panel, what we then do is we insert a fan. That fan then can do two things. We can depressurize a house, which is the most common, or we can pressurize a home. Now, why would we depressurize? Why would we pressurize? Well, depressurization, especially in the colder months or the warmer months, will actually make those air leaks more visible. However, we may have to pressurize a home. And why we would pressurize that home is if someone was, had allergies or very allergic to potential mold spores or anything that we could be bringing in through those air leaks. So that is very, very important to know which way we're actually going to perform that test. And that's up to the technician or the specialist that's out there actually testing the home. So what it also does is it accurately measures the home leakage. Now, how do we do that? We do that with a high precision manometer. The most important number needed about a house. I don't care the square foot. I don't care the cubic foot or cubic volume. I don't care the house when the house was built. No other number is more important than actually that blower door number. So let's talk about the manometers that go with that blower door, and also manometers that you can get and how you can test some certain things. So what we do is we actually start by taking a hose connected to our manometer to the outside of the house. And what we're doing with that is we're going to get the outside conditions and factor those in, such as wind and things like that when our fan runs here. We make sure all of our combustion appliances are off within the home. We are going to monitor carbon monoxide constantly. It's on our hip while we're doing this. And we do that for the safety reason. We have to make sure that homeowners are aware. Ashes are cleaned out of a fireplace, dampers closed. We don't want to pull ashes anywhere around the house. Even if we pressurize, we're still going to blow those around. So we ask that those be cleaned prior to us going out and doing a test on the house. Then what we're going to do is once we actually get our manometer connected to our blower door with relative to the wind and air pressure outside, we're then going to go ahead and set our manometer to 50 pascals. Now, this is a universal pressure for measuring home. So that's why we use 50 pascals. And we adjust our rings to the door accordingly to achieve that 50 Pascal rating. And then what we have to do is we have to understand and read in what we call CFM 50. And what we mean by that is what is the CFM leakage of the home relative to the 50 pascals of pressure that we're running our house at. And then what we do is we follow that up by doing zonal readings and thermal imaging. And we get the homeowner involved so they can actually see what's going on within their home. Let's talk about a manometer that you could get, that you could test without a blower door. So this is going to be thanks to TEC, the Energy Conservatory, and TrueTech Tools. They did an awesome presentation last week regarding this manometer. It's new. It's called the DG8 by TEC. It is a very cost-effective, highly accurate single channel manometer, whereas the blower door manometer, the duct leakage tester manometer, is going to have a dual channel. So there are many opportunities to use a single channel micromanometer. This also is Bluetooth. Okay, so you can check static pressure with it as it's showing there on the screen. Its accuracy is good as any other manometer for a blower door or a duct leakage tester, which is amazing that they got that technology and that precision in this little manometer here. And it's designed for key building pressure measurements and applications that we can do by using the HVAC system. And it's only $549. Also, if you order it on TrueTech Tools, you can get a discount. So, manometer testing. When and why? I can do it without a blower door. It can be a first step in understanding potential causes for the homeowner's comfort, maybe even energy usage, air quality, building moisture issues. It's a lot that you can do with this little manometer here. Now, why? Well, residential fans in our HVAC systems are going to average between 500 to 200 CFM. There's going to be pressure imbalances caused by that blower running in our HVAC system, which can drive infiltration, exfiltration due to duct leaks, doors closed, multiple things within a home. Also, these pressure differences can affect energy use. Again, indoor air quality, radon, combustion spillage, which we talked about earlier with that CAS testing and stuff. Comfort, building durability, moisture condensation. So comfort concerns when homeowner about rooms or areas that are more uncomfortable than others. So we can actually test that. And I'll show you guys here in a second how we do that. We utilize our HVAC blower, and we're using that to your advantage and our advantage for testing the house. And then again, like I said, combustion appliance zone testing. So we can actually check spillage or backdrafting of water heaters. And what I'll do is I'll share that video from TrueTech Tools and TEC. I'll share that to everybody via email. Like I said, the water heater spillage and operation of everyday ventilation. So how do we test a room that may be uncomfortable? Well, what we do with our manometer here is we're going to check the room pressure with reference to the main body of the home. So what we do is we start with all doors open. And as most of us know, homeowners will close doors at nighttime, especially if they've got little ones, kids, teenagers, whatever, in-laws staying, and they just close doors. So what we do is we start with all our doors open. And then what we're going to do is we're going to close one door at a time. But what we're going to do is we're going to put our hose from our manometer into a room of concern. And as we actually start to close that door, we're going to see that reading on the manometer change. And what you want to do is you want to check that difference. And if that delta is ever greater than plus or minus 3 pascals, now we need to consider how to keep that room more connected. It could be as easy as leave your door open. I'm dealing with that at a house right now. It's a workout room. You're in there 45 minutes a day. Why are you closing it? Leave it open. Close it when you need it. Or do what we call a transfer grill, or even add return to a room. So start with all doors open, close the door you're testing with your tube connected to the area or room for that testing, and then be within that plus or minus 3 pascals. Here's a little video. We're doing a zonal testing with our blower door the other day, and I walked to the I walked to the upstairs and I noticed it felt like I was kind of walking on a cloud. And watch this video.
Okay. Yeah.
So what's actually happening is I have that blower door depressurizing the house, which is pulling in and just exposing all that air leakage. And with that air leakage there,
Okay.
it's actually sucking out on the bottom plate underneath the carpet and lifting this carpet up. We need to be aware of that. We need to be concerned with that. So move on to our thermals and our leakage and how we check it here. This is a job that we actually did yesterday in Cincinnati. And we were depressurizing the house as well. And you can see right here on this bottom right picture, all that air leaks, all those air leaks were actually pulling in dirt and dust, and this house was just flipped. And they were having major issues, and they just purchased the home a couple of years ago. So it was flipped about 3 years ago, and they've been experiencing nothing but major problems since. So you can see here the pattern, the thermal pattern on the bottom left picture of the thermal imaging camera here of the air leaks coming down on a second floor. Same thing here. And then you can see all the air leaks that we have on this new staircase that they put in. And you can see the heat actually being pulled in from the attic facing that side of the sun was facing that side of the house. And it was afternoon, and all that heat was actually starting to kind of transfer down into the home as well. So we suspected that the summer was a big problem. And once we actually mentioned that, showed that to them, they completely agreed and said, man, you got it spot on. And it's not even summer. So dust pulling down walls and into the home, thermal showing air leaks around the home, and that gradient pattern of air leakage, significant in problem areas for the homeowner, was exposed. So once we get that CFM50 number, what does it mean? Well, we actually have a nice little scale here of how leaky your house is, and this actually goes into our reporting for our HVAC 2.0 group and our HVAC 2.0 software. So what we call this our LAIR, LAIR. And that is our leakage to air infiltration ratio. Basically, what we do is we take our CFM50 number that we got, we put it on this scale in comparison to the square foot of the home. And you can see here on this house that was tested, they're at a C minus, D plus. And what that means is we have to understand the type of home that we're dealing with first. So yes, we know their number, we know their layer, but what type of house is it? First of all, larger homes, they need a lower layer number or leakage to air infiltration ratio number to become more controllable. Now, why is that? They have more volume, okay, compared to their surface area. And where do the air leaks occur? On the surface area of the outside walls. So it takes a little bit more control or lower leakage numbers to actually get under control. Knee wall attic homes that we run into, those could be Cape Cods, bungalows, Victorians, arts and crafts homes, areas above garages that were converted and now connected to the home. They get outside of control once they exceed our layer number of 1 to 1. And then slab homes. So just like larger homes, they should be a little bit lower on our layer ratio, our layer number, because they got a slab underneath them. So they don't have those leaks on the bottom. So they should be tighter, and they usually are tighter. So it's all about control. Okay. So down here at the bottom of our software for our HVAC 2.0 group is we want to be around 1 to 1. That's when we actually can become more controllable with our HVAC equipment. Once we're outside of that range, we can't guarantee or promise that any system that we put in the home is going to overcome any issues from draft, cold spot, stack effect. Leaky homes are very difficult to make controllable with just that HVAC alone. So it's all about setting those expectations. So let's talk about the science and physics of the home. Hot goes to cold. We all should know that. Hot goes to cold. Heat will always flow to cold or less heated areas until it equalizes. High humidity goes to low humidity. Moisture, like temperature, also will equalize, or it likes to equalize. Air and moisture travel from high pressure to low pressure. So it's lazy. It moves to the largest and easiest paths to travel. And that's how we can actually do quite a bit of testing and even our aeroseal process. Okay, as we use that high pressure to low pressure when we pressurize duct systems to actually seal them. And gravity goes down. However, there's one more. Wet goes to cold. What does that mean? Well, moisture in the air is drawn to cold surfaces. And then that's where moisture vapors will start to turn to liquid. It's that darn dew point again, right? So, dew point. What is dew point? Well, it's the temperature at which air cannot hold any more moisture. So think of it like a glass of iced tea outside on a summer day. What's going to happen is condensation is going to form on the surface due to the temperature being below that dew point. Things will get wet, but it's okay if, and most importantly, that it becomes dry. Okay, so it's if things are going to get wet, they got to get back under control. Since wet goes to cold, this is why basements or crawl spaces seem damp or are damp and musty. So think of it this way. Summer heat and humidity with air leaks to a basement, such as on a rim joist or perimeter of the home, will leak into that basement or crawl space. And it's likely going to start condensing on cold basement walls because of dew point. And what is a byproduct of that? That cold, damp, musty crawl space or basement that we run into. So, with careful consideration of the HVAC equipment, the ductwork design, or proper ventilation and dehumidification options can be a great way to help control these. So, heat transfer, we have conduction. Okay, that's where the process of which heat is directly transmitted through a substance when there is a difference of temperature without movement of that material. So as you can see in the picture on the left there, when you're holding a hot plate, it's a transfer of heat through that substance to your hand. Convection is the movement caused within a fluid by the tendency of hotter and therefore less dense material to rise. And colder, denser materials will start to sink under the influence of gravity, which consequently results in the transfer of heat. And finally, radiation. Radiation is the process by which energy is emitted by a heat source in all directions and directly to its point of absorption. Getting control. Air leakage is, again, the most important. Heat and moisture travel through air. That blower door test measures that leakage. So what we want to get is control over the heat and the air and the moisture flows in and out of a home, as well as inside of the home. It does not have to be perfect. It's very, very important to understand it does not have to be perfect. It just has to be under control. Has to be adequate. Every home is unique and different. You could have two houses the same across the street from each other, and I guarantee you they're going to be different. Jump into our side of understanding the HVAC system. There are 6 functions that we want to consider controlling. How many does a house typically have? Most houses have 0. It's where we start talking about our indoor air quality and other things that we can actually do to help. But understanding the house is very important in helping. So let's start with number one. Number one is load matching. Well, how do you load match? How do our comfort consultants load match? How do all comfort consultants across the nation load match? Rule of thumb, go out to the road, stick your thumb up, see how big the house is. My favorite one is a little one of the different house diagram. You go out there and you just make it fit inside the house, and it tells you your tonnage of your system. If we don't test, we guess. However, if we responsibly avoid responsibility in making the homeowner understand that during one of our free estimates and our free quotes, that they're more than likely going to get a like for like on sizing, they'll get to choose the efficiency they want, but they'll more than likely get a like for like on sizing. That's us responsibly avoiding responsibility if they choose to go that path. So your car, okay, can have all those different levels. You can turn your fan up, you can turn it to auto, you can change the temperature. That's great. So here's an example with blower door testing when we're talking about the proper sizing. This is also another house that we did. Here's their current equipment. 135,000 BTU furnace. With actually measuring the blower door number, getting the blower door number, which I said earlier is the most important number to have, I'm able to actually true it up to their energy consumption, perform a proper engineering analysis, and show what size furnace they should have with their current leakage here. So even though they got 135,000 BTU furnace in this house, they only need an 80. If they air seal, we can actually get away with a 60. And this is on a 3,000 square foot home. The cooling load is also the same, and we got to be very, very aware of cooling load, in my opinion, in our climate and in our climate zone. And that's because with the new EC motors and everything, and how they're trying to overcome the pressure restrictions on these poorly designed duct systems, is that we're not going to remove the amount of moisture that we need to in homes, and we could end up in trouble. So our current equipment here that they have in the house is a 5-ton. They only need a 3.5, 45,000 BTUs with their current leakage. However, with air sealing, we can actually get them under 3 tons. So what typically happens with that oversized HVAC system? Well, we get big temperature variances. So on this graph here, it shows the heat runs, shuts off for a long period of time. Starts to get cool or drafty, heat runs, shuts off. Continues that cycle throughout the day. Usually we get comfort complaints. Same thing in the summer months with cold rooms, or winter months with cold rooms. Is the same process is happening. Proper size HVAC system with good load matching and proper load matching will actually look more like this graph here. A little bit more even, a little bit more consistent, a little bit longer runtime, a little bit more efficiency out of that furnace or air conditioning system that we're putting in, or heat pump, and a happier homeowner. What that also does is it's critical for comfort. The longer run times that we have on that piece of equipment as well will get the surface temperatures up. And when the surface temperatures get up and they're within 2 to 3 degrees of that thermostat, you are now at ultimate comfort for that homeowner and minimal complaints. So smaller and multiple stage equipment. This graph here, I love this because it talks about load matching with various HVAC pieces of equipment. So our design temperature that we go out when our comfort consultants actually put this information in is it should automatically be pulled to our climate zone in our area. And we don't want them to change that number. Because again, it's called design for a reason. It is at that temperature is when that system should be running 100% to achieve that temperature within a home. How often is it 3 degrees outside? Not very. 3%, 2% of a winter? How often is it 95 degrees outside, 92 degrees outside? 10%, 8%? So we're saying that it's oversized 90 to 97% of the time. That's going to be comfort problems. So understanding the home, multi-stage equipment, better commissioning, better setup is going to allow us to actually control it better and have a happier client and a more comfortable client or homeowner. Number 2 is filtration. So what we look at here is our sizes of our microns of particles and the different MERV ratings that we'll typically run into. 8, 11, and 13. You can obviously see here smaller particles at a MERV 13 filter. That would be lovely to have into most systems, but there are duct design and duct considerations to consider when we're recommending this type of filter. I'm going to tell you how to get around that and how to actually still get that good of a filter into a system. So the higher the MERV rating, the denser the filter is going to be, which also means that it can increase our static. So it's important to understand the pressure drop across each filter and selecting this right filter for the home and for the system that you're dealing with. And again, ductwork key in keeping that TESP, or that total external static pressure, down and under control. More reason to install a BAD. You'll understand what that means in a minute. So number 3 and number 6 is going to be humidification control, or controlling that humidity level within a home. So in our presentation last week for humidification in my home, what we talked about is the low end, the high end, and we're all used to seeing the Stirling scale or the Stirling chart of that 40 to 60% is that optimum zone. I'm going to tell you that it's not going to be 40% in the middle of winter. And the reason being is because it's going to have that potential of reaching dew point. That surface temperature is going to be colder than dew point, and we're going to have moisture problems. So we may see humidity down to 15, 20%. Understand dew point, have the conversation with the homeowner, make sure they're aware of it. Any control that we put in should have an outdoor sensor with window protection set up on the controller. And during the summer, I really don't want it any higher than 50% humidity in the home or in areas of the home, such as a basement or crawl space. So we have sensible heat versus latent heat, heat versus humidity here. Sensible heat is the temperature at which we all see on the thermostat. We all understand because that's what the thermostat's reading, right? That's our cooling load. However, there's a lot of latent heat. And what I mean by latent heat is humidity, moisture, grains of moisture in the air. And we have to know how much of that moisture we need to move out of a home. But how do we know? We don't unless we test. So again, sizing, very, very important, and understanding latent and dew point. Off seasons can be difficult. Spring, fall, we call those shoulder seasons. Those can be hard to control humidity in a home. So people open windows. It's nice enough. I want to open the windows outside. What do we typically see in the morning? In the spring or summer when we go outside? We see dew on the ground, right? Well, chances are if you're seeing that outside, you're going to see that inside if you have windows open and you don't have some sort of control. So we have options. There's multiple options on fixing this and helping with this, even in those shoulder seasons and or those off seasons of spring and fall. And obviously the first one that we typically will go to and talk about is whole house dehumidification. Understand when we're installing a whole house dehumidifier, though, we can either do it in dedicated areas, which is my personal and favorite choice of installing them, is if the HVAC system's the right size and everything with load, that's going to take care of the living conditions or the living spaces, and the whole house dehumidifiers, spot dehumidification, and crawl spaces or basements. The other option is if we have a total electric system with like an infinity in a 5-stage or modulating unit, new green speeds, we can actually use reheat to reheat that air to dry out that moisture and pull it out of the airstream. So we have a couple different options here. Now with reheat, you have hot gas as well. We typically will not see nor install that. Number 4 is fresh air. How much fresh air do we need? Well, we're going to do that by controlling mechanical ventilation. And we have 2 options to do that. One is a fresh air controlled damper closest to the exterior walls where that damper is going to be installed and controlled. And we're going to run that back to the return. Or we have our energy recovery ventilators, our ERVs. There's also HRVs, but again, in our climate zones, we're not going to be installing HRVs. So how important is fresh air and what's the impact of carbon dioxide? Well, here's a little chart that shows you what higher carbon dioxide levels do. And you can see here at about 1,000 parts per million of carbon dioxide, we're going to start getting into some down here into the average areas. Once we get even higher, you're actually going to start affecting cognitive function. They say over 1,400 parts per million for an extended period of time of carbon dioxide levels, you could actually reduce cognitive function by up to 30%. So with everybody staying in their home with everything that's going on with COVID and everything, understanding carbon dioxide levels and that fresh air is very, very important. And just educating the clients is what we need to do. So we want to pay attention though. So if we're installing ventilation, if we're installing that ERV or that mechanical damper, fresh air ain't always fresh. Depends on where you're pulling it from. Be careful, be aware, know how to install it properly. And then also make sure that you have a plan in advance. So if you need advanced filtration or even dehumidification, you're aware of that. Circulation, mix it up. Low air movement and circulation can lead to even more even temperatures, including those surface temperatures that we talked about earlier, which are key to overall comfort. Discuss with clients that the humidity levels could increase without the right pieces of equipment or air sealed home, especially in the off seasons, the shoulder seasons, or even the summer, if they are running that fan in the on position. Again, the Infinity system, the Infinity controller, having that and that control to run that in a low speed or an EC motor set up correctly with the dip switches is very good for helping with this. It also allows you to filter more too. So basically, like a car HVAC system, it has 5 of those 6 functions. The only one it doesn't have is humidification. So we have our mixing, our load matching, our fresh air from out, our filtration of that fresh air, but we don't have humidification. Why do our vehicles have more than our house? Why can't we have all of these in our home? All right, so getting to bad. We call this our badass HVAC section. All right, and what I mean by badass is big air drop, air source system. So start with that. Let's start with the bad, the big air drop. You want that return drop as wide as your media filter. If you got a 16 by 25 media filter, put it in the horizontal position, make it 16 by 25. What that's going to do is it is going to be a reduction in our total external static pressure. You're going to have the best potential drop, okay, across that filter. You're also going to have better filtration. Earlier, we were talking about the MERV ratings and stuff. With a bad, you can get up to a MERV 13 filter or greater. There's multiple ways to achieve this, okay? So here's a bad drop. No pun intended. This is what we see every day. This is what we need to be aware of and understand what's happening. So we have a typical return drop with that airflow to the left there going down. What happens is there's a lot of turbulent air where that's going back over to the blower. The higher velocity in that return air drop equals more turbulent air, which is going to then have a higher pressure drop across your filter, which equates to higher overall duct pressure, or TESP. And it's poor filtration. You can't put in a MERV 13 filter. You're going to have to go back with a fiberglass filter in a situation like this to just try to prevent the equipment from overworking or failing. EC motors with replacements are going to increase this total external static pressure, which in turn is going to equal more energy consumption and more service calls. Premature failure, more warranty. Hopefully at some point, because the manufacturers are getting smart, especially with these connected controllers, they're going to stop the warranty. We need to be ahead of that. We need to be aware of it for our clients. That's not going to be a fun conversation to have. Higher total external static pressure will also lead to other system component failures as well. Coils, heat exchangers, compressors. It's all about that proper air movement through the system. So variations to bad, or that big air drop here, is if you don't have room, not saying you have to have the filter in the horizontal position. You could put it in the vertical position, but anything that you can do with vanes or turning vanes inside of a drop is going to help reduce that turbulent flow, which is also going to help reduce that pressure drop. Just offer it with every opportunity. Just do it. So all 6 functions of HVAC, heat pump, air handler combo. So here's a picture of kind of a design. And what we have with all 6 functions here is we've got our load matching, proper size equipment. Number 2, we've got our filtration. You can see we've got it in our horizontal position in this scenario here. We have our dehumidification with either reheat or a standalone dehumidification or ventilating dehumidification unit. We've got our fresh air. This is showing a damper coming in. You could also run it through a ventilating dehumidifier back into the system. We've got our mixing because we've got a good TESP. We can run that fan in a low position that will help move air through the house. And then we've got our humidification that we can add to our systems as well. So these are the 6 biggest functions and things that we can do for our badass HVAC design. This is an attic combo. This is going to be only recommended in spray foam attics. Again, we may not see too many of those where this roof decking is spray foamed, but that's how you can get humidification, obviously safety pans, things like that underneath it. So we won't see too many of those, so we'll skip by that one. And then here's one that we'll probably see quite a bit. And this is a hybrid variation or dual fuel system. So heat pump with our gas furnace, same thing with our BAD, our filtration, our humidification. We have what we call a ventilating dehumidifier that takes air in from outside, runs through the dehumidification, helps filter it, dehumidify it before putting it back into the system. Also, it's spot dehumidifying, or you can dehumidify from the whole house. So, elements of badass HVAC. Just a recap: load matching, right size, variable speed equipment. Once we understand the home, we got the blower door number, which is that most important number for the house. We can actually properly load match the system. We can have better filtration. We can go MERV 11 or greater with the same size duct on that return drop. Dehumidification, either reheat, standalone, or spot dehumidification. Fresh air, which is controlled fresh air, either through a duct or through an ERV, HRV. And mixing with that BAD for low TSP and usage. And humidification, controlled and based on outdoor temperatures. So I want to give a shout out to Nate Adams. So if you guys want to learn more, dive deeper into some of these subjects, He has a book out that's called the Home Comfort Book. You can purchase that online. Also, Facebook users here, we have a group called HVAC 2.0. It's advanced discussion for comfort troubleshooters. If you want to, you could always look for that page on Facebook, join it. There's a lot of good discussion going on there. I will tell you though, if you're going to post something or say something, have thick skin. These guys and gals are just there to help. With that being said, thank you. And now I will take any questions that we may have. We're right around that, getting close to that hour mark.
So Jeff, if I could interject on something, guys, I hope you're paying attention to this, because one thing I just noticed in all this is probably the top 5 questions you guys will get out of homeowners that aren't in a breakdown situation were answered in this class, this presentation. Why is my upstairs always hot? Should I run my fan all the time? Why my basement is musty and smells bad? Guys, everything's in here. So if you missed something, go back and watch it again, and take notes. That way you can kind of fast forward, rewind through the video and listen to it a second time. You know, why is my son's bedroom on the second floor always hot or cold? He just gave you all the information. You know, it's just up to you guys to pay attention and pick up on what the answer is. So if you didn't catch it, go back and watch it again, because that was a lot of good information.